Throughout this presentation, we will be talking about iron and what makes it such a unique element. This presentation will also be discussing the melting and boiling points, the oxidation states, the colorful compounds, the extraction of iron, the common compounds that iron forms and we find in our daily lives. Here is some background information about iron. Iron has an atomic number of 26 and an atomic weight of 55.8. This makes it part of the transition metals in the periodic table. It was first discovered 5000 BC in Iraq. It is the fourth most common element in the Earth's crust. It is found in a solid state. We as humans also have iron in our blood, which helps with the transport of oxygen throughout our body.
When looking at periodic trends, electronegativity, electron affinity, and ionization energy increase moving left to right and along the period. Atomic radius increases down, right to left, which is opposite.
Iron has the following values for electronegativity 1.83, electron affinity 15.7 kilojoules per mole, ionization energy 7.9 electron volts, and atomic radius is 124 picometers.
Melting and boiling point of iron. Boiling point of iron is 2,800 degrees Fahrenheit, 1,538 degrees Celsius, and 1,811 degrees Kelvin. The boiling point of iron is 5,184 degrees Fahrenheit, 2,862 degrees Celsius, and 2,135 degrees Kelvin. Iron compounds are generally used as thermoconductors because of their high boiling and melting points.
The most common oxidation states of iron are +2 and +3. However, there are other possibilities such as +4, +5, and +6. +6 is a very rare oxidation state of iron. The +2 and +3 oxidation states of iron, since they are the most common forms of iron, are the oxidation state to memorize for iron. There is no compound or chemically important circumstance in which the oxidation state of iron is equal to the total number of its valence shell electrons, 8.
Iron produces many colorful compounds. The following three are the most common. Iron 2 hydroxide, which produces a pale green color. Iron 3 hydroxide, which produces an orange-brown color. And iron 3 oxide, which produces a red-brown color. Also, iron 3 oxide is more commonly known for its use as a catalyst found in the Haber process.
The extraction of iron ore is done using a vertical shaft furnace that produces liquid metals by the reaction of a flow of air introduced under pressure in the bottom of the furnace. It burns at approximately 1,800 degrees Celsius and then decreases towards the top to as low as 400 degrees Celsius. The extraction of iron starts with the collection of iron ore from the earth. The ore is then crushed up and separated using gravity, and is washed with water to remove clay, sand, etc. The concentrated ore is then mixed with coke and limestone. This is then placed into the top of a huge container called a blast furnace.
Some of the common compounds of iron include iron 2 carbonate, which has a molar mass of 115.9 and is an iron supplement for people with anemia. Another common compound includes iron 3 oxide, which has a molar mass of 159.7. It's a reddish-brown color and it's used as a pigment in cosmetics and paints.
Iron 3 acetate is 233 grams, used in dyes and mordant. Iron 2 nitrate is 180 grams, used in the process to make sodium amide. Iron phosphate is 357 grams, ingredient and fertilizer.